Microfluidics from Harvard. They call this zero-cost diagnostic technology, right? So the target for this is, you can look at, to measure glucose, sugar, for example, in developing countries. The Genome Research Institute, the DNA assays. I mean, that really revolutionized how we can access the genome. And so microfluidics, clearly at the liquid level, really revolutionized some of these technologies. So what we're really trying to do is to do essentially the same thing, except we take the liquid away and we use air. Okay, so we use air floating on the channels, in the microfluidic channels, right? That's the working gas. Again, our focus is PM because it doesn't really exist any good examples of using microfluidics for particulate matter. And by the same token that liquid microfluidics revolutionized the biomedical industry, we believe that air microfluidics can really revolutionize the field of air quality measurement science. Right? You can really take some of these pretty complex and heavy instruments now and miniaturize them, right? Using microfabrication technologies, we can really do some complex things. And that's really the focus of our air microfluidics group, which actually is a research consortium between Lawrence Berkeley National Lab, now University of Illinois Chicago, UC Berkeley, and EPA. Okay, and I'll talk more about actually the group itself a little bit further on. So, if you look at microfluidics in general, and specifically at air microfluidics, basically what microfluidics allows us to do is to create these lab-on-a-chip applications, as I mentioned, reduce the size of some of these much bigger instruments, right? So the reduction of sizes is a particularly